So, hello everyone. My name's Brian Meacham. I'm here conducting this research effort on behalf of the ICC, really trying to take a little bit of a, I won't call it a deep dive, but a broad view on where we are in the US in terms of thinking about performance-based building codes and how we've evolved in the 20 years since the ICC Performance Code was first developed, and to see how the different engineering disciplines have advanced, how we're looking in terms of different goals, objectives, societal expectations that have changed. For example, when the first edition came out, we really didn't have anything on sustainability or resilience or energy performance or indoor air quality. So structure was in, fire was in, but both those disciplines have changed a lot. So the aim here is to get a broad set of opinions from people. We've done some of that through a survey, and now the roundtables are intended to have, groups from within disciplines and practices, so structural engineers, fire, building officials, and so forth, to really have a discussion about what they see as opportunities, challenges, state of practice, and where we need to go. So that's the purpose of today around the structural engineering and the different kind of hazard design that you folks do. I want to thank Bob very much for kind of pulling you guys all together. He's been my go-to person to tap into the key people in the structural engineering side of things. And so with that, that's enough about me. What I'd like to do is kind of go around the room, as it were, ask you to, introduce yourself, say who you're representing or why you're here and what you hope to gain out of this, and then we'll launch into the discussion. So I'll kick off with Bob.
Sure, and also what I'd suggest, just so everyone knows each other's background, is share a little of your experience with performance-based design and the specific hazards that you've implemented performance-based design with. So I'm Bob Pacquilli. I'm a senior principal with Degenkolb Engineers. I primarily have been involved with seismic code development, and then in the past couple of years also just translating that to both community resilience and also to other hazards through some of my code activities. As far as my practice in implementing performance-based design, it has been predominantly for seismic forces and designing for earthquake with existing buildings more so than new buildings, but I have been involved with some major, particularly medical centers, doing performance-based design, and also data centers and manufacturing facilities. I also have a very little bit of experience with performance-based fire design that I want to thank Eric in particular for enlightening me on and helping me understand. And then also about 15 years ago, I had a significant practice in anti-terrorism and force protection with blast, impact, and progressive collapse.
Great, thank you. Don Scott.
Thanks, Brian. Don Scott, a senior principal with PCS Structural Solutions up in the Seattle-Tacoma area. I'm actually here representing the NCSEA Code Advisory Committee, but also chair of the ASCE 7 Wind Load Subcommittee, and the principal investigator for the pre-standard for performance-based wind design that SEI published. Most of my work is in the Northwest. I do a lot of seismic performance-based design, but also am the chair of the SEI Resilience Committee. So all of those things kind of flow together.
Great, thank you. Erica?
Hi, Erica Fisher. I'm an assistant professor at Oregon State University. My background is in seismic and fire, so I have experience with performance-based design in seismic, but I mainly now work on the fire side and developing performance-based design for fire, which is pretty deterministic at this point.
Great, thank you. John Hooper.
Hi, John Hooper with Magnuson Komensick Associates in Seattle. I do right now, I'm the chair of the ASCE7 seismic subcommittee and did that for a long time. If in the performance-based design world, I've been doing seismic performance-based design of mainly tall buildings for nearly 20 years. And that's the majority of what I do. We are starting our third PBD wind project today. So we're starting to break that, open up the book, Don, and trying to do that on our third building right now. So that's my background.
Great, thanks very much. Therese McAllister?
Yeah, thanks, Brian. I'm Terry McAllister. I'm with the National Institute of Standards and Technology, or NIST. And you can think of us as a research institution without students in terms of teaching classes, but we do have a lot of graduate researchers and sometimes faculty working with us. So I probably started thinking about fire in terms of performance-based design. I helped get the appendix in ASCE 7 and then helped work on the guidelines that support the performance-based design criteria for structural engineers. And since then, I helped Don with the performance-based wind design, I guess, pre-standard that came out. And my current activities focus heavily on community resilience and identifying metrics to measure performance at the community scale and trying to find ways to link that back to the building scale so that we can go back and forth between community and building scales.
Thanks very much, Terry. Jim Harris?
I'm a practicing structural engineer in Denver, Colorado. I am here because Bob Pacquilli asked me to be here. So that's who I'm representing, if you will. But my history in terms of performance-based structural engineering goes back a very long ways. I used to work at the National Bureau of Standards, which is what is now NIST, where Terry McAllister works. And in the 1970s, that institution was very interested in performance-based design. And it had its heritage in the United States in something called Operation Breakthrough, which was an attempt to change the way building codes caused increases in the cost of housing. And that had its heritage in rebuilding Western Europe following World War II. And it was a very interesting concept. I worked with Bruce Ellingwood, who many of you will recognize that name, and in writing a very generalized performance-based standard for structural engineering. Didn't have quantitative measurements in it very much, which is a function of, which is an important thing to get resolved, I think, in the ICC Performance Code. Since then, I've had a lot of involvement in the same things that several other people have mentioned. I've chaired the committee for ASCE 7. I chaired at one point the seismic committee for ASCE 7. So I've had some experience on the seismic performance side, which is different than what we were looking at in the 1970s for sure. But that's enough, I think.
Thanks
And
very
snow
much.
recently, Jim, you might want to add.
Say it again, Bob.
Snow.
Oh, well, yes. I've had a long interest in loads of all kind, and I've been I guess a background prime mover in changing what ASCE 7 now has in it for snow based upon work that we've done here in Colorado over the years, such that we now have a reliability targeted snow load set of maps for the United States as a whole that shows up in the 2022 edition of ASCE 7. And we sort of did an adaptation of what was used to develop the ground motion maps for seismic to apply to wind, to apply to snow, particularly in areas where what I would call the northeastern U.S. model didn't really work very well.
Great, thanks very much. Jennifer.
Hello, thank you, Brian. Thank you, Bob, for inviting me to join this. I think I'm here too to just kind of be in the loop of what all is going on. I am staff at ASCE, particularly in SEI, the Structural Engineering Institute. We developed ASCE 7, which many of this group is, as you've heard, a big part of. Also 41 that Bob leads. A lot of that performance-based material that goes into that document, as well as the document that both Terry and Don have spoken of, the PBD pre-standard for wind, was developed by SEI, funded by Charles Pankow. So we have had some purposeful, I would say, specific development in those topics. Fire is another one. As Erica mentioned, Terry brought in with her group fire into ASC 7 and 716. Since then, we've developed some other tools to support that effort with performance-based. And separate from the actual work of the standards development, we have a committee working on performance-based design efforts, like kind of in a framework perspective, as Terry was mentioning, kind of overseeing, you know, what is the outcome for all of standards, where are we looking at for SEI to develop some of these documents going forward, and many on this call are also involved in that back loop, if you will. So it's nice to be invited. Thank you, Bob.
Thank you very much. Seth?
Seth Thomas with KPFF Consulting Engineers in Portland, Oregon. My background is in seismic, tsunami, and flood load design, performance-based design. I've done also some progressive collapse on projects. I do new and existing buildings, either seismic retrofits or new buildings for performance-based design, including some tsunami vertical evacuation performance-based design projects. And I'm also on a number of ASU 7 committees as well.
Great, thanks very much. Chris Shoemaker.
Hello, my name is Chris Shoemaker, and I'm with the State Department, the Overseas Building Operations Bureau. We rely on IBC to inform our international construction projects for embassy construction. And my background is in blast design and protective design. And just, I'm also in the staying in the loop category, just essentially an owner's rep. And my organization is very interested in the performance-based design direction, and just looking forward to hearing the conversation. And I know we would greatly be interested in hearing conversation. Thanks, everyone.
Thank you. And Jitender.
Hi, so I'm from across the border. I work at the National Research Council in Ottawa, Canada, as a technical advisor for developing the seismic provisions in the National Building Code of Canada. And I'm here because we have also launched a similar initiative. Canada does not have a performance-based code for seismic, but what it has is a precursor to that, which is the objective-based code. We are trying to coordinate between the effort here and the effort that Brian and his team are making to come up with the new generation performance-based code. So I'm very happy to be here, and thanks, Brian, for inviting me. I'll be mostly listening, so thanks a lot.
Great. And so thanks again to everybody for being here. And what I want to do now is kind of open it up to discussion. I might, lean on Bob a little bit, in making sure everybody's involved. But, some of the things we want to really tackle, or what I'm trying to figure out is, how do we think about performance? What we had in the ICC performance code, in many aspects, it was more like the objective code that is in Canada, not really talking about really quantitative performance targets. What are we looking at? What do we need to get to? And how our structural engineers in these different hazard areas, advanced over the last 20 years, and where should we be going? So just small items, and I'll open it up with that.
And obviously, the part of the reason I reached out to all of you is I think we've all had conversations about what it would be like, and have been involved in the efforts that, probably are a long time coming to look at how we could replace or at least have an alternate to our prescriptive codes that's purely performance-based. And so recognizing that we have different kind of hazard design philosophies at different levels of maturity with performance-based design, one of the questions could we at this point, with what we know, develop a performance-based standard, and what would it look like for structural loads? So please, someone feel free to jump in and share your opinion.
Yeah, Bob, I'll jump in first. And I think the answer is yes. We have guidelines developed for both seismic and wind. Wind's a pre-standard, but the seismic guidelines have been around specifically for tall buildings for 10 years and being used successfully in high seismic. So we have some go-tos or go-bys and figure out if that's the kind of direction you want to take. But there's enough out there that is being implemented today in the seismic world. And as I mentioned earlier, we're on our third wind PBD project using the pre-standard that was developed that Don mentioned.
So maybe I can ask too, because probably we'll have some people who will look at this that don't really understand what you do, maybe say a little bit about how you see performance-based design. So for example, I spoke with energy engineers yesterday, and they're thinking about, they have a performance design that is for compliance, which is different than what they would like to see, which is an outcome-based approach. And so trying to frame this, what do you mean by performance? What are you trying to achieve, and how does it differ from what some of us would consider the prescriptive design?
I'll chime in from the fire side. I'm really involved with a lot of public policy that's occurring in Oregon right now, and I can say that a lot of the push on the fire side is not coming from structural engineers or civil engineers, or really people who have that background of knowledge, like people on this call who understand the background in the development of performance-based design, community resilience, et cetera. So I would love to see a framework, like a hazard independent framework that can be adopted for for the WUI, for fire. That's so, because I just see right now that you see a lot of fire protection engineers or just people in the Forest Service trying to reinvent the wheel, and not trying to build off of what has already occurred, or trying to redefine terms that already have a definition. So I would love to see more liaison from the wind, the seismic into these other hazard areas. Because I think that those who've gone through implementing this performance-based design in wind and seismic, and even all the work that happened in tsunamis, there's so many lessons that were learned along the way that can be transferred to other hazards so that we can push forward. But instead, they're trying to start from scratch. So even just understanding, like even just performance-based fire design, right? Like I think that we throw that term around quite a bit, but we're not doing performance-based fire design. It's not probabilistic, it's all deterministic. And so even just having that wherewithal to use the right terminology so that you can draw parallels between the hazards, and when you say performance-based design, it has an actual meaning rather than something that's beyond just prescriptive.
You're on mute, Jim.
Thank you, Bob. So let me add some really deep background. There was a framework developed across Europe and the US, and Canadians were definitely involved, Jatinder, in the 60s and 70s, that the overall framework was sort of a hierarchy of things. The top level was a non-quantitative performance requirement stated in terms that you can literally talk outside of technical circles about. What does society expect? And you know, if you're going to a city council or a legislative meeting of some kind, you can talk about performance requirements. And for any performance requirement, there were, generally speaking, at the next level down, a set of performance criteria. These were quantitative measurements. And for some structural loads, for example, they were well understood even in the 1970s. And there were evaluation methodologies to come up with the numbers to judge whether the criteria were met or not met. And literally what has been going on for the last half century has been a fundamental development of additional evaluation methodologies to demonstrate that performance that's desired will be delivered, oftentimes in a conditional setting, but that conditional setting is part of setting those performance criteria. As you delve into it, it turns out the devil is in the details, both in terms of what the quantitative measurements are in the performance criteria, and they're certainly different for different loads, like an order of magnitude difference between earthquake and gravity loads, for example. You know, we're much safer, if you will, for gravity loads than we are for high seismic situations. And the evaluation methodologies to come up with the numbers. It all takes a lot of commentary to explain it all, but that overall framework is, I think, important to keep in mind as we move forward.
Thanks, Jim. And I'll just jump in briefly there. I had pulled together a PowerPoint, which I don't know that I had sent, that kind of overviews some of the history. So it goes back to the performance concept that Jim was talking about, Operation Breakthrough. You can actually still get the reports from the HUD website, which is really interesting reading, you know, for those who want to go back and look at the framework back then. It also includes what some of us call the NKB hierarchy, which was the Nordic Committee on Building Regulations, which laid out a structure for performance codes that, you know, is very attuned to the performance concept as published in some of the HUD documents. So that framework, I think, is helpful because at least 15 countries around the world use that framework in the way that they've structured their functional or objective or performance-based codes. And so that's something to keep in mind, and probably, you know, I can share that if I hadn't already. I thought I sent a link to that, but it's helpful to have that because that's one of the basis that I'm trying to get everybody kind of on the same page with. And I think from there, you know, how you quantify and how you design and how you move forward and how that varies by the different hazards or disciplines becomes interesting, because that's, you know, where the real critical challenges occur.
If I could just offer a couple of thoughts, and I apologize, I'm going to have to go in a few minutes. I just had other commitments today. But thinking to just two issues. One is how this document might reference other performance-based standards that exist or guidelines. And the idea of being maybe hazard agnostic or neutral, you know, might help with that. The other thing is terminology and a little bit of a structure. You know, this idea of performance criteria, either for goals or acceptance, you know, objectives, all these terms are probably used in various ways, and it would be helpful moving things forward to have a clear set of understanding about what those terms mean in performance-based design. And sorry, just one more thought. Erica, you made me think about this distinction about completely probabilistic versus a scenario-based performance-based design. And even in ASCE 7, right, we have the extraordinary load criteria for things where there's not enough data or information that we're able to characterize the hazard probabilistically. So we then go to scenarios, and I think we need to recognize that as well as part of our going forward with performance-based design.
Yeah, thanks, Terry. Those are all good points. And, maybe I should have been a little bit clearer too at the start. One reason we didn't, or I didn't send out kind of a common set of framework and definitions was I didn't want to start from a biased perspective. I wanted to see what the disciplines are thinking. And so far it's a little bit as expected that everybody looks at it differently, which I think is, I want the kind of the actors to recognize that that problem exists so that they can come together on commonality. So I think this is helpful. And then documents that, you all might have where you've defined terminology, scenario-based, whether performance-based has to be probabilistic and all the rest is helpful to be able to compile a common set of resources for people in the discipline. And it was interesting, Terry, that you mentioned that even within ASCE documents, there's different perspectives. And I think that's a big challenge, as Eric has said, because a fire protection engineer that comes from a mechanical or combustion background or a systems design looks at things completely different than a structural engineer doing structural fire performance, yet they both call it performance-based design. And so it's really no wonder that a code official sits there and says, what are you doing? So this is why, really trying to understand. And, I don't know anything about tsunami design, but talking about vertical evacuation, and fire protection engineers are vertical evacuation the other way, there's all these, terms and approaches that may not be, lining up, again, causing confusion. So it's exactly what we're trying to tackle.
And I think even in the structural arena, we found that when we were working on the NIST community resilience framework, that even these qualitative objectives sometimes crisscross, where, with seismic, there was this desire to focus on shelter in place as a performance objective. And for WUI, that's like the absolute worst thing you could be doing, or tsunami. And so having to recognize that we probably can't simply use one overarching philosophy for all the hazards, as much as it would be great to have a unifying framework. And so but I think it's this concept of first having the qualitative descriptors of what are we trying to do. Like I go back to the 1955 or the 56 commentary to the 55 Blue Book in SEOC, where they just simply stated that, very little to no damage in a minor earthquake, repairable damage in a moderate earthquake that did not impair the ability to function, and that there was no life-threatening injury or damage in a major earthquake, and that the building would not collapse in the largest possible earthquake. And just simply, and succinctly stating kind of a tiered performance objective that both recognize there are different magnitudes to every design hazard, and performance is different. But then, within that, I think where sometimes performance-based design has fallen short is in translating the qualitative to the quantitative. And we certainly struggle with that, because some people have, and where the performance code currently is, and I think where it can be challenged is that it's very deterministically thinking in terms of locking in this hazard to this performance objective. And as we know, that's an impossibility. There is no absolute certainty. And so we need to find a risk-based approach. And something Jim shared with me about 7-8 years ago, I think was really interesting is how back in the early mid 1970s, the ATC3 committee that kind of laid the basis for the seismic design really looked at the hazards that one or the risk that a person would undertake in various other aspects of their life, and kind of marrying that to the risk that they should be taking on when they set foot into a building. And that maybe we've somewhat, with all the other stuff that we've done, we've lost sight of that kind of comparative risk, and that it, the unifying thing across all performance-based design really should be this concept of risk, and also marrying it with societal expectations. And the last thing I'll say is when we, 10, 12 years ago, when we started this Spur Resilient City thing in San Francisco, which I think, kind of laid the basis for a lot of the community resilience thinking. One of the surprising things was picking up the city of San Francisco's post-earthquake recovery plan, which was written by emergency planners, and looking at when they believed they were getting buildings back online and buildings would be available to implement this procedure. And then knowing from a structural engineering standpoint for a design level earthquake, what performance we are willing to accept for these buildings, there is a complete disconnect, because they're thinking in terms of time to return to function, and we're talking about a reliability of not collapsing. And so it's really, I think there's a lot of great information out, and it's kind of synthesizing it all so that we can really form this code that both supports societal expectations but also reproducible designs.
So let me ask something and get a response here. Is there anyone who does not think risk is an appropriate base for establishing performance expectations in buildings from a hazard perspective?
I think it's one of them, but I don't know that it's the only one, because as we're seeing with this, and it's across a lot of different hazards, is reliability of function is possibly as important.
That's good to know, so, but if risk is one of them and reliability of function, what are really the key drivers? And I'm thinking in terms also of Erica's ideal that there would be a hazard agnostic framework. And just as an aside, Australia is trying to use risk as a basis for performance for all hazards. And in their 2025 edition, they've got actual quantitative risk values for fire infrastructure that they're testing with the market to see if they can use those as a primary basis for building performance analysis. So as we talk, or as I talk to different disciplines, you have risk, you have functionality, what else is it? And how do you see risk being accepted by the code officials as a basis for performance?
I think in setting the level of acceptable risk, one has to think about the other cost to society, the cost for compliance. And so you can't, although we don't have completely adequate methodologies for what I'll call a true cost benefit analysis, you can't ignore it. If you did ignore it, we would either bump up the seismic forces by a tremendous amount, or reduce our safety against gravity, load, and wind by a significant amount, and neither one, I think, is an acceptable thing. There's a balance between risk and cost that has been struck in a very political, not in terms of partisan politics, but political in terms of multiple people with different objectives getting together and hammering out a compromise as to how safe is safe enough for a given circumstance. I don't think we're going to get away from that. I don't think we can be so pure as to have a number that works for everything.
Any other thoughts on that?
I have a question, maybe a question back to Jim and the rest of the group is, then who sets the acceptable risk levels? In the seismic world, we have been setting them kind of in our own little space. How do we push that back out and really get society to understand and helping define that risk and what's acceptable? Because that in the seismic world, I've been struggling with my whole careers. We do what we do, Jim, and we feel comfortable. But as Bob said, emergency planners they're disconnecting with what they think we're providing and what we actually provide. So how do we get over that hurdle?
You're exactly right, John. That we don't open the curtain often enough to show people what's really going on, and this is an effort that can help there, but it's bottom line is it is not easy, and big changes happen after really disastrous events.
And I think a lot of how we've set risk, but at least my understanding of it is frankly been back calculating from what we do or what we've been doing. That even, reading some of the original LRFD reports, the summer camp report, I mean, one of the metrics that was used to establish the target reliability, and obviously Jim will correct me if I'm wrong on this, but I think was what we were getting with our existing factor of safety. And John, as you know very well, we picked the risk target for the seismic because that's what kind of things look like when you
follow our product procedures. That's what you get. That's kind of what you get.
Right. Well, isn't this, in my opinion, kind of what we're talking about here, bridging that, what we're doing and what we think is based on that kind of that Jim describes between cost and risk, and also now kind of facing the music, if you will, with the public and with owners to say, here's the building that we will build per the building code. If you're with that, great, but we could also move it over here to this category, which you all do with your owners on these projects when you talk about building performance.
Yeah, I mean, I think a big part of it is that discussion and, following, I guess the National Academies had a report back in 1996 about risk characterization and the need for an analytic deliberative process where you bring the analysis together with lay persons, stakeholder perspectives, and you get a joint agreement on what your risk and how you achieve it. But we don't seem to be able to operationalize that concept very well.
Yeah.
The going back to Erica's thing about the hazard neutral part, with wind, the hard part you come up with, it's not the structure, it's the cladding that is the issue. And that's where most of the damage is, and the loss of function and everything occurs with a breaching of the components and cladding. And so that's a total different discussion of the risk that you associated with it when you come into that different hazard aspect. We haven't had many buildings that have failed truly from a structural standpoint because of high winds. It might be that they lose without losing their cladding. If they lose their cladding, then that becomes the issue. So there is a difference when you start going down those hazards and what they mean from a risk standpoint and really from a functionality standpoint.
And I'll add on one of our projects in particular that became a major point of contention in terms of what we could do and what we wanted to do, because the cost of doing what ideally we wanted to do was stunning because of the need for a cladding system that had never been designed before.
Yep. Well, it's the best example, of course, is the Joplin Hospital that got all the cladding got destroyed. The hospital had to be torn down. The structure was fine from the loading that was there, but the structure had to be torn down because of the loss of the cladding created an infection problem. So they tore the hospital down to rebuild it. That was the best solution that they came up with, but the structural system itself was fine.
So maybe another question, around this, acceptable, tolerable risk level, and thinking about a framework. There is, the matrix approach in the current ICCPC with, listing different performance groups and tolerable levels of impact and damage expectations. Maybe that's, I guess it's a question, is that still a reasonable construct within the structural engineering field for different hazards? And could that be something that takes a step towards a common basis, because your impact levels and what's acceptable can change based on how you reflect the magnitude of the hazard and the performance group within which you assign a building. And that, I think, was the original intent, but is that not something that could be expanded to maybe wind, tsunami, and fire in a more robust way than was available 20 years ago? Or has nobody used that?
I think, it's like a good point that Don brought up is, are we talking about risk of structural collapse, risk of structural damage, or are we talking about like loss of the building, like financial loss? So I think those are two different, right? Those are two different things. With a fire, I mean, quite honestly, the smoke and the water damage from the sprinklers are going to do way more harm than the fire itself, and cause loss of the building. But again, the structure might be okay. The building might be completely stable structurally. So it's a performance-based design. Is it just for the structure itself, or are we looking at the whole building, including non-structural components, which are probably worth more than our structure itself?
Yeah, Erica, that's why in the pre-standard we added a whole chapter on components and cladding for that very reason, because that is where the financial loss is from a wind event. It's not the structural, it's the cladding loss and what the ramifications of that cladding loss are, which is usually water infiltration, is the big issue.
And from seismic, if you talk about reliability of functionality that Bob mentioned earlier, it's going to be the non-structural. You're going to drive that. It's not going to be the structure, and depending on the size of the event for sure. But if it's a moderate event, it's not the structure. It's the cladding, it's the partitions, it's the elevators, it's the stairs. Yep.
Do you all collectively think that the building code, even the IBC, addresses that? Because the code is life safety.
No, yeah.
It doesn't.
Well, I think it does for seismic because of all the work that we've done with Chapter 13 of ASC 7.
Yeah, it does a better job than it did a long time ago, for sure. Yeah.
But outside of that, I mean, I think it doesn't. And if you want to get into where we have this other thing that hasn't been brought up, which is the enforcement of the code, because the greatest performance-based design doesn't necessarily provide the building that actually complies with that performance-based design. And the reason I bring that up now is because where my experience has been the non-structural components is really where the enforcement breaks down to a spectacular degree, actually, where you could have some of the most intricately designed structures, and then the building structural engineer of record rotates off the job, and it's a mishmash of random consultants doing design build work, if even that, for trade vendors that are installing the component system.
So in a way, I think this is, part of, similar to a discussion I had with the MEP and energy people in terms of, is the performance design for compliance, or is performance-based design for actual building performance and outcomes down the future? You know, generally, we have a system that is compliant at the time of the handover of the design, not necessarily that the building will actually meet that performance. And is that even the right mindset?
Yeah, you know, one topic that came to my mind as sort of an owner's rep that we're keenly, you know, focused on is durability and maintenance. And I don't know if that category of performance is in the same line of thinking that you're focused on as far as designing to hazards, but just I think something we struggle with or find challenging is when we specify performance goals such as durability of concrete structures in hazardous, you know, corrosive environments. There's sometimes a disconnect between our desired performance, you know, as the owner versus what the codes really empower the designers to you know, target. So it's just, that's just one example where it's not necessarily life safety, but it is that desired outcome. But just that disconnect makes it challenging to enforce strictly through our, you know, the codes that we have at our disposal.
Yeah, I guess I would say, from my perspective on this overall effort, you know, I think durability is something that should be considered. And, you know, if you look at codes around the world, New Zealand, for example, has durability clause. They actually have targets in terms of number of years and serviceability requirements around that. I think, you know, maybe on a bigger picture, you know, one of the concepts that's in the discussion, you know, in society today is resilience. How do you design a resilient building that does not have some sense of durability and serviceability over a defined lifetime? And how can you build that into your code if you, or how do you design a building for that? Or how do you expect that if you don't build it into the code? So I guess I would expect that to be part of the discussion, you know, so it would be a question of, you know, how might we go about getting there? How would we even frame that discussion?
An overall performance code needs to have those subjects treated. And it's not fair to say that what we have for our ordinary codes today completely ignore it, because they don't. I'm going to leave in 5 minutes or so to attend a series of meetings of ACI 318, the Concrete Building Code Committee. There are a lot of parts of that code that are very much focused on durability. You know, there are serious requirements on the concrete mix designs based upon exposure to sulfates, chlorides, et cetera, that wouldn't be there if it was purely a life safety code.
But I think as we're seeing with some recent events, durability and life safety are starting to, or at least people are starting to wake up to the importance of durability.
Absolutely, yes. Some of us are deeply involved in that one.
Yes. But Jim, on that comment, it's not consistent though through the material standards or the codes itself, right?
It is not.
So how do we then take these different good ideas and,
Well,
different focuses and bring them together? Or do you?
Perhaps the ICC Performance Code is a good place to begin to bring them together.
Yeah, because right now they're disparate. I see ACI, I see AISC, TMS, the Mason guy, they're all doing their own thing, but not doing it to what they think is the right level, but they don't connect. Maybe they do, maybe they should, maybe they shouldn't, I don't know, but we need to pull together somewhere.
You're talking about life cycle now.
Yeah.
To Chris's point, exactly. It's not just the performance per collapse prevention. It's the whole life cycle, which gets into the resilience and sustainability and those other topics you mentioned at the top of the hour there, Brian.
So I guess the you know, the bigger question, and, you know, I'm conscious that people will be dropping off, but, a big question is, does the structural engineering community, and I know this is just a small subset, think we should be moving in that direction? Is it the right thing to do to really be looking at life cycle, to be looking at resilience, to be looking at durability, to be adding really objectives to the performance code that better represent the expectations we have or society has in buildings, which is what we should be aiming for, balanced with cost, as Jim said. But if society's not happy with the way buildings are performing, what are we missing, or what should we be including, and how do we deal with that?
Oh, well, Brian, one thing to note is, and Jennifer and I have had this discussion quite a little bit, the new ASCE Code of Ethics requires us to consider the resilience and the sustainability in our designs. And so if we don't codify it or introduce those concepts into the code somehow, how is our profession going to meet those ethical obligations that they have?
We're going to call it a performance code. It should include all things related to performance.
And I think this is where, this balance that Jim brought up is going to really come to the forefront, because when we start thinking in terms of life cycle, I think there's a lot of opinions about it, but when you actually take these opinions and try to translate them into actual design metrics, it starts to get skewed. I mean, ASCE's currently embroiled in a heated debate about that with their sustainability standard. And some of the things that are in that draft have really rankled the different industries, because what's considered acceptable what was considered acceptable or life cycle via the implicit way we're currently designing, when you actually start defining design lives, you're required, and then you marry those design lives with the current state of the practice, you start looking at very different designs and possibly like industry shifting designs. And that is something that doesn't get codified without a lot of negotiation, because when you start changing the balance of what we're currently doing to, all of a sudden favor not favor the incumbent, that definitely doesn't happen without a fight. And so it's not that that's something we should be shying away from, but it's the realities that we have to recognize, and especially given in some respects the kind of like kind of really novice level we're at right now with assessing a lot of these things outside of safety.
So I'm going to sign off in just a moment here, but ISO 2394, which came out with a new edition about 5 years ago. And previously it was focused purely on reliability of structures, has become more of a risk-based approach to structural engineering, and it includes some concepts of what I'll call cradle to grave. All the way through what's called, decommissioning and disposal. I'll try to find the pertinent excerpts and send it to Bob and Brian. Okay.
Great, thank you.
I have a quick question, Brian, of the group, and the thing that we struggle with in practice is how much performance should be required and how much should be offered to the client to bring to the project. What's the thought from you and the team, and how much of this will be you have to do all this, or if the client wants to do it or the community wants to acknowledge something, they want to do it in their community? How do we deal with that range of performance options, if you will?
Yeah, I was going to say it's similar to what the EPA deals with the required versus recommended with most of their pollution. things. And Brian, go ahead.
Yeah, and I was going to say something similar on the energy side. What a lot of states have done have adopted a base code and then what they call a stretch code. And so there's this alternative that would typically be in as an appendix that would be, so some communities could actually adopt a stretch code that goes beyond what was deemed the minimum performance in the code. And then, of course, clients could always go beyond that. But I think, the discussion that really needs to be had first is what should be the minimum that we should be targeting. And I don't even think we've had that, for a long time around performance. We tried to have it 20 years ago, but I think it was too new. People really didn't understand, this framing that was attempting to be implemented. So if any further activity is done, it's discussions like this that have to be had on a broader scale. And it would be really helpful. And I guess this could be a question to Jennifer, but to the broader group as well. Does ASCE, have kind of a strategic plan or a strategic objective for, where performance, should go in the future, where we're at, what we can do now, where we would like to go, and how it would fit into the code structure, because we kind of need that from all the disciplines as we move along to kind of benchmark and look ahead.
I think too, it's important that the performance code first and foremost does establish not just the minimum, but the means to achieve the minimum, because it would. Part of my practice is dealing with manufacturing facilities, data centers, and other, kind of business critical things. And what we find is there's a lot of differences in what people are selling to clients as to the vehicles to provide improved performance. And that some are definitely going to provide improved performance, and others are kind of just, for lack of a better term, hand waving. And so by having a performance code that first sets the minimum and then sets the means to achieve the minimum, then you can talk about the stretch goals and the ways to prove, in a reproducible manner that you're providing better than the minimum.
That all makes perfect sense. Yep. I like that.
Yeah.
So
Might be not necessarily this group, but I know in the past, I just had a thought on this. And when we talk about those stretch goals and achieving like some of those higher performances within communities, let's say, and or specific buildings, it becomes a broader life cycle building performance discussion and a bigger carrot for the industry in terms of insurance rates and different valuation and stuff for those properties. So that's a little bit bigger than this discussion, but it definitely could be a driver in some of those stretch performances as well.
yeah, and I think, we see that on the wildland fire side as an example, or any coastal community or flood prone community. People are spending a lot of money to rebuild over and over again. And, one question is why you're building there in the first place. But if you're going to be allowed to be building there, why are you not doing something more, to be more resilient? And I think, the country as a whole thinks about that issue now much more than it did 20 years ago, but there has to be, kind of a focused discussion on, what it takes, where should we be targeting, and what does it take to get there?
But I think that you bring up a very interesting point with flood, and I'd love to hear Seth's perspective as someone who's got some battle scars from trying to look at, moving a profession that's very mature like flood to maybe a more comparable reliability that we do with other hazards.
Yeah, we're definitely fighting the what everyone thinks is a good idea versus the cost of doing that. And we probably didn't do the best job of articulating what the costs actually are, which we're working on. But I think everyone recognizes that the flood community in general is doing a terrible job of designing structures that give good performance. And if you do it smart, the costs can be minimalized. But I think, that's going to be, anytime you move the line, you have to fight that perception of costs.
So couple of questions I wanted to kind of put broadly, and I don't want to keep people any longer than the good discussion, and it's been good discussion, but one thing is, what do you see as the biggest opportunities being missed currently by not having more robust performance approach? Are there any real opportunities being missed, or is this all just good theoretical discussion, but isn't going to get us anything?
Well, I think one thing that I would bring up is that some of our code provisions contradict each other for different hazards, and this was part of the reason for the wind pre-standard for the PBD, was that as John's designing his tall buildings, when you get to the upper levels, they're controlled by wind or sometimes instead of seismic, and then those provisions contradict each other, what you're trying to accomplish for the structure. And that happens more in other, with fire and different aspects throughout our code. So a lot of the provisions contradict each other on really what you want the overall performance of the structure or components to be. And we're fighting those contradictions all the time. And that's where the performance base would allow us to get beyond those.
I think this is very related, but the highly prescriptive nature of the code kind of boxes you in sometimes as an engineer. The example I like to give is we did this, covered walkway, but it's seismic design category D, so it had to be a special moment for him, even though it was controlled by wind by a factor of 10. And so we spent all this extra money to design special connections and do all this stuff that really weren't needed. I tried the R of one thing, but it wouldn't have changed the design other than it would have made it cheaper. But yeah, I think the highly prescriptive nature is driving a lot of costs in some areas.
I couldn't agree more. I mean, I think economy, and this actually translates to a part of sustainability. I don't think gets enough recognition, and then structural engineers don't get recognition is when we optimize the materials in a structure, that we are contributing to sustainability a lot more so than previously. I mean, I think we're moving that way with life cycle costs to be able to quantify that. But right now, as Seth said, there's you look at a prescriptive design versus a performance-based design, and some of the work John's company has done has really demonstrated the amount of waste that can be in a structure because of these prescriptive codes. And we have an opportunity to pull that away. And the other thing is innovation, that the performance-based code really gives you the vehicle to bring in things like tall mass timber that we just were, for whatever reason, previous iterations of code writers had decided that this was not a good idea. And so when something, the preponderance of people in the profession think something is not a good idea, the only way you can break that mentality seems to be by having a performance-based approach to demonstrate equivalency. And so, I think, resources, as we talk about, are going to become more constrained. We're looking at how can we minimize energy, and then obviously a topic we've been kind of staying away from with this discussion because we wanted to focus on new buildings initially before we even delve into the existing building. But the ability to reuse an existing building, it really depends on being able to demonstrate an equivalence, because most new buildings would never meet today's prescriptive standards, but that doesn't mean that they're not good enough to be reused or repurposed.
And that's probably a discussion for another day, not just existing, but that gets to the tolerable risk issue. I mean, there's generally a sense that if it met the code at one time and doesn't anymore, then it's okay. Yet that's also where we see a lot of the losses. So there's a real dichotomy about, when something is acceptable or tolerable from the loss side as compared to when the costs are incurred. So a lot of interesting discussions there. But, a lot of good ideas on opportunities missed, kind of the corollary question, what are the major roadblocks to getting there? Maybe a couple of plant a couple of seeds that some disciplines are concerned about. The how to say this politely, the competency and capability of practitioners to actually be able to do a robust performance-based design, and likewise the ability of those reviewing and approving designs to understand what's being done and to be able to either agree or engage someone who can make that decision on their behalf. Maybe that's not a problem on the structural engineering side, but I just tossed those out there as things to ask about.
I'll jump in with an example on the seismic side, because that's the world I really come from. At the beginning of the performance-based design for the new taller buildings that we engaged in, again, 20-ish years ago, it took some time to really get our we thought we were competent, but we then get the whole review process, the jurisdictions, et cetera. It took some time, guys. It really did. And I think we're very much in a place where it's acceptable, and the peer review process, which is been used throughout this whole thing, because it's required, in my humble opinion, works if you get the right people. So I think we could use seismic as that example. And again, as I've mentioned a couple of times already, we're doing the performance-based wind stuff. And the key there will be first the jurisdiction saying, yeah, go ahead and do it, which thankfully they're letting us do, and getting the backup of peer reviewers that can look at it in a way that blesses it. In the end, Brian, I'm not sure all structural engineers need to do this. I'm not going to subscribe to the fact that for this to be successful, 100% of structural engineers or any engineering discipline has to engage in this necessarily. Right. It may be a small percentage, maybe 5, 10, 15%. I don't think that should keep us from doing something. That's right, in my opinion. Those that want to go down that path and provide that service and that result, let those engineers do that, and let it go from there.
So maybe a quick follow-up there, just get a general sense. What do you all think is kind of a reasonable percentage of buildings that, really might need or could significantly take advantage of performance-based design? Not that what you learn can't go into the prescriptive, but, what are we looking at? 5%, 15%, 50%? What do you think is kind of realistic?
Well, Brian, I probably more agree with John, and it's in the 5 to 15% maybe of the structures. However, there are probably components of most structures that at some point don't quite fit the code provisions that we have, and so you could use performance-based design to supplement. Though I'm going back to your previous question a little bit. Most of it is education of when you say the word performance-based design to a lot of the smaller firms that haven't even thought about it, that is almost scary to them. They don't have that concept, and having done a few performance-based design in our office, it's just about education. It's not. They have the skills. They learned them in college, mostly. They just are scared by the terminology and don't want to move forward. But with that, so like I said, a lot of it's just education. But I agree with John, is that it's probably 5 to 15% of the buildings max that would really use a full performance-based design, really full performance-based design, probably more toward the 5% range than anything else. But it's something that can be used on portions of of a lot of buildings to do it.
And I'll throw out because I completely agree with what John and Don are saying from the standpoint of the full design. But I think one of the things that performance-based design opens the door for, which could capture a lot more of the buildings, is the ability for different, kind of subsets of buildings to have guideline documents that are based on and hopefully blessed as providing the performance level. I think Don is well familiar with a very specific wind load design methodology that we seem to have to keep in the design standards because it's applicable and has been validated for one. While it's a small class of buildings, it's a highly reproducible type of building. And so, moving away from trying to have a one-size-fits-all performance or prescriptive code, you can start having these, more specific, whether it be material or system-specific design guides that are, providing the equivalent performance for a very narrow class of buildings.
Brian, if I may, very great discussions. I learned a lot today. I just wanted to echo what John, Don, and Bob, you were saying. Even in my discussions with the experts, the thinking here is that performance-based design, the framework should be general. It should be generic, could apply to all kinds of buildings. But when we actually get down to developing authoritative guides or documents, we could pick and choose the areas where we see more chance of success. And these could be situations like high hazard areas, like high seismic hazard areas, where the uptake would be more. Or there could be a situation when you're dealing with multi-hazard, because codes don't deal with multi-hazard. Or you're dealing with resiliency, where the community is totally, recognizes the risk that is in the community for that particular hazard and is more conducive to talking about performance-based design. So that's the thinking that we are trying. Let's first catch the extremes where if we pitch performance-based design, the chances of success are going to be more, and develop the entire environment that would be needed to do such projects. I did a comparative study of New Zealand and the US code, ICCPC. The New Zealand code, the performance-based code is the law, right? It's the regulation. But in US, IBC is the regulation by the states, and ICCPC is a model code. Now, the New Zealand code does not have the design performance levels which you have. The only, one of the compliance path is the building code like ASC 7. So that's a minimum kind of a thing. But what the advantage you have in US is that you have this multi-level design solutions, whether it is through ICCPC, whether it is through US Resiliency Council, whether through the LA and San Francisco tall buildings. And you have so much information on ground motion histories and, all the FEMA work. And so when I look at from across the border, I see there is a lot of things that just need to be tied up to develop solutions for specific scenarios. We may not be able to develop a performance-based code solution, code yes, framework yes, but would it be better if we just target specific scenarios where we feel that the chances of success of a performance-based approach are more? Thanks.
Thank you. Great comments. Maybe just to follow up on that briefly, England is relooking at their whole building regulatory structure. That happened to have been triggered from a fire, the Grenfell Tower fire of a few years ago. But partly what they're looking at is, requiring a new approach for what they're calling complex and high-risk buildings. So it's a little bit the same way. If you can find a way to kind of define when the level of complexity or the risk associated with the occupancy or use of the building, or the risk to, society if something happens with the building as requiring a higher level of performance. Maybe that's, a target to aim for with a code that can bring all of these components together, and then perhaps be able to trickle down parts of that into more of the daily use of other types of buildings. I'm getting a lot of nods, so that might be something that we'll want to think about. Okay, I think we're coming up pretty close to the end of what was scheduled as time. What I'd like to do is, ask kind of once around the room if there's any, last one or two items that you think we really ought to be thinking about as we do this. And then also at the end, just to kind of give a sense to Bob and me if you'd be willing to engage again in future discussions and tackling some of the issues we didn't get to today on actual design, quantification, some of those other issues that we said are important, but we didn't want to get too far into the weeds today. So with that, I'll just kind of go around the room and I'll pick on you first, John.
I happen to be sitting next to you on the Zoom screen. Is that what it is, Brian? I'll answer the last portion of your question first. Yeah, I'd be happy to do the quantification because it's really important. Because of my practice, what I've done in my daily job and what I'm doing for fun, volunteering, doing a bunch of other stuff. So the answer is yes. I think we've covered everything I wanted to have covered today, Brian, to be honest, the whole range of issues and the whole acceptable risk versus cost. We can't lose sight of that. And I do feel strongly that we do need to pull back the curtains and let society know what we're giving them. And then we could give that minimum level of performance. So this has all been said, but I just want to reemphasize a couple of those points that we heard here this morning.
Thank you. Don.
No, I agree with John and be happy to participate further in the future. Probably the one thing that I, again, don't want to, having sat on about 3 of these different panels over the last 5 or 6 years, is consistent definitions of the performance objectives is critical. And it really goes to what John described as pulling back the curtain of really what we are providing. That's to me, and to make that consistent out across multiple industries. It's not just structural, but it's multiple industries that we need to be consistent with.
Great, thanks. Seth?
Yeah, agreed. I couldn't agree more on what John and Don said. And yes, I'm willing to continue to participate. It was brought up earlier, but I'll re-emphasize, let's not lose sight of all the deferred design items that go into our buildings that are usually catastrophically wrong and very important, like stairs and MEP bracing. I can't tell you what terrible designs I've seen go into high performance-based buildings or attempt to go in. I'm the bad guy who rejects submittals left and right because they just don't work.
Great, very good. Jennifer?
I kind of wanted to circle back to one of your very first questions, Brian, that you brought up was, do you think we're ready to do this? And I actually do feel strongly that we're ready to do this. It's not going to be easy, but I don't think, I mean, it sounds kind of like pie in the sky, motherhood and apple pie kind of stuff, but if we don't do this, who's going to do it? We're not going to be happy if someone else makes us change our documents and our requirements. So we may as well just go and make them into something that we know we can achieve while, kind of using that concept John's describing of pulling back the curtain to say, hey, this is what we're currently designing to, this is what we're currently giving to society and all these performance issues. I think society has kind of caught up to that, maybe changed quite a bit since the topic was first discussed maybe relative to Jim Harris's work in the 70s when we didn't even know what we were talking about. But now I think we understand that from a societal level based on discussion of resilience, witnessing building performance, not match our expectations in some areas as kind of just the general public. So I do think we're ready to do this, and I would for sure be happy to help stay in the loop. But thank you. I think this is a great first step or continued step.
Great, thank you. Chris.
Hi, yeah, no, I don't think I have anything really else to tack on. I mean, I think just speaking again, just from the owner's rep kind of side of things, I think that, you know, so much, especially on the government side, we are kind of comfort level, I think, has traditionally been in this prescriptive mindset. You know, the walls have to be 12 inches thick, you know, just move on. It's just so like checklisty. But the reality of it is we would actually get so much more out of our buildings by shifting that mindset into the performance realm, just because, you know, especially we deal with these international sites, having the consistency of just the performance requirements would actually give us more freedom and flexibility to accommodate, you know, just the dips and valleys that we encounter versus something that we think is all encompassing, like a prescriptive requirement. So that's just like a very broad, you know, 50,000 foot statement, just saying, I think we would be really, you know, supportive and gain a lot from this. So, you know, just looking forward to where that goes. Thanks.
Great, thank you. Jitender.
Not much more to add, but from where I sit, like they say, the grass is greener on the neighbor's lawn. It certainly is greener, and there's a lot of grass. So it's just a matter of, you know, bringing it all together. So I feel if anybody can do it, it is US, because the maturity, at least in seismic, because that's where I'm from, there's tremendous amount of effort and results that are available, and it's a matter of having the right group of experts like these to tie them all up. And from my side, I can, you know, if it is useful, I can bring in some Canadian experts to join the discussion as well. Thanks.
Great, thank you. And I'll give it over to Bob for the last word.
I think it's been encapsulated so well with everything everyone else has said. Just to hit on a couple points is one, a unifying, you know, not just the consistent definitions, but the reproducible methodologies. This is something, and I know John, because I can sympathize with him. Our firm's being on the other end of a performance-based debate and philosophical discussion about one facet of a design and how that can really mess up the, you know, kind of success of not just a project, but of performance-based design, because the last thing we want is to get into a situation where we can't get the experts to agree upon what is actually the means to achieve the performance. And it's a really important thing that I think can't get overlooked. And also for society, because if you have different people purporting to do performance-based design, and they're giving vastly different things to the owner, that's also an issue. And so that having a document by a reputable organization like ICC that also then, you know, reaches out to and harmonizes with the standards developing organizations like ASCE, the various material standards, and also other companion documents like ASME and ASHRAE, because there's and we didn't really touch on it, but I know this has come up a lot on ASCE 7 is when you get into the non-building structure arena and you start having overlapping standards with like IEEE and telecommunications standards and AWWA and the water and wastewater things that you start finding these disconnects because there's different organizations and different groups of people purporting these things. And so being able to create this, you know, unified and reproducible methodology, I think is going to be essential and have this ultimate like great benefit to society.
Great, very good. Nice way to cap off the discussion and keep us on the good path forward. So with that, I'd like to thank all of you, and we'll call this session to a close, and I look forward to our continued discussions. Thank you
right.
very much.
Thank you all.
Thank you.
Hey,
Thanks for the
Bye.
invite. Take care.